With this problem, we are asked to use a known Taylor series to find the Taylor series about x equals 0 for f of x equals x squared times natural log of 1 minus 5x, and then to state the interval of convergence. And then once that's done, we are asked to find the third derivative of this function. The third derivative can be found by using the product rule, but it's a bit tedious. Okay, now our starting point for this will be the known Taylor series expansion that natural log of 1 plus x is equal to summation n equals 1 to infinity of -1 to the n minus 1 x to the n over n. That is our starting point. Okay, so for the problem at hand, we have natural log of 1 minus 5x, and we're multiplying it by an extra x squared. And before I do that, I'm sorry, the convergence is going to be here for -1 less than x less than or equal to 1. So that is the interval of convergence for natural log of 1 plus x. So for the function that we're given, x squared times natural log of 1 minus 5x, all I do is everywhere I see an x, I replace by -5x. So this is equal to summation n equals 1 to infinity, -1 to the n minus 1, -5x to the n over n. And then I have an x squared here, so I need to put an extra x squared in the front. And this will converge as long as -1 is less than -5x less than or equal to 1. Okay, I will work out the series first, and then I will simplify this. So over here, I have x squared summation n equals 1 to infinity of -1 to the n, -1 to the -1. Then I have -1 to the n, 5 to the n, x to the n, all over n. Okay, so I'm using my law of exponents to kind of separate this out. -1 to the n, -1 to the minus, -1 to the minus 1, -1 to the n, 5 to the n, x to the n. Okay, so I have summation n equals 1 to infinity. X squared I can bring inside. That becomes x to the n plus 2. -1 to the -1, that is 1 over -1, which is -1. These combine to become -1 to the 2n, and then I have times 5 to the n over n. Okay, and to do the simplification here, I remember that -1 to the 2n, that's the same thing as -1 squared to the n, which is 1 to the n, which is just simply 1 all by itself. And so this is just 1, so I end up with just simply negative summation n equals 1 to infinity of 5 to the n, x to the n plus 2 divided by n. Okay, now let's work out the interval of convergence, so which means I need to isolate x here. So to isolate x, let me divide everything by -5. When I divide by -5, the crocodile changes directions, and so I have to flip the inequality. So divided by -5, I get 1/5 is greater than x is greater than or equal to -1/5. Or alternatively, that -1/5 is less than or equal to x, which is less than 1/5. And so that is the interval of convergence. Okay, for the last part of the problem. The last part of the problem says find the third derivative at 0. All right, to find the third derivative at 0, remember the Taylor series looks like this. Summation n equals 0 to infinity of the nth derivative at 0 over n factorial times x minus 0 to the n. So to figure out the third derivative, let's figure out the x to the third term. The x to the third term is going to be the third derivative at 0 over 3 factorial times x to the third. Alternatively, the x to the third term can be written as, well, negative 5 to the third, so 5 to the first, pardon me, x to the third over 1. So if I let n equal 1 here, I get 5 to the first, x to the third, 2 plus 2 plus 1 over 1. So these two things have to be equal. So equating, these are two different ways of saying the exact same thing. I get that -5 is equal to the third derivative at 0 divided by 3 factorial. And so that means that the third derivative at 0 is equal to -5 times 6, which is -30. And so that is the third derivative at 0, f triple prime of 0, without actually computing the third derivative explicitly.